Hello, welcome to this lesson of our study of differential equations. Okay, so in this lesson we'll go through the solution of a differential equation. So when you say this function given or this thing given is a solution to a given differential equation, what do we mean? Okay, so if you have not subscribed to my channel yet, kindly subscribe to support the channel, like my video, comment, and also share as well. Okay, all right. So a solution of a differential equation. So a solution of a differential equation is any function. Okay, so it's supposed to be any function at all. Okay, sorry, we are talking about a solution, so just any function. This is very important. Okay, so it's any function at all that satisfies the given differential equation on a specified interval. Okay, so some functions can work within a certain range or interval. Okay, so in that we have two types of solutions to a differential equation. Mostly when you are solving a differential equation, you first get a general solution and then you use your things or your information given to find your particular solution. So you always get this a general solution, and then we'll use the general solution to get a particular solution. Okay, now let's talk about the general solution. So the general solution is a formula that gives all the solutions of a differential equation consisting of arbitrary constants. Okay, so let's say if you have a certain differential equation we don't know, let's just write this. Let's say y prime minus, let's say y equals some 0. And if we say, okay, this is not true, I don't know, I've not tested this, but if you say that this is a solution to this, okay, now since we don't know a and b, this a and b, and they are just arbitrary constants, for every value of a and b you pick, you get a different solution, you get a different y of x. Okay, if let's say we pick a to be 1 and b to be 2, you get y of x equals s squared plus 2x. Now if somebody chooses a to be, let's say 3, and b to be, let's say 3, you get 3x squared plus 3s, and that one too is different. So it means that the general solution actually contains all the solutions. So it's a formula that gives all the solution to a differential equation. Okay, and it consists of arbitrary constants. These are the constants we are talking about, the a and b, these ones. Okay, I hope you get this. So let's go to the next one, which is the particular solution. Now with the particular solution, it do not contain arbitrary constants, and to get the particular solution, we make use of the conditions given or the information is given. Okay, so sometimes the particular solution, you get a solution like this. Let's say y of phi of x equals something being a solution to, so here there is no arbitrary constants in here. Okay, all right, so let's pick examples on solutions to differential equation, and then we go. Okay, so now I have this question here that is saying that we should show that y of x equals c1, this one. Okay, c1 cos s plus c2 sin x is a solution of the differential equation this. Okay, so our differential equation here is d squared y ds squared plus y equals 0, and we are supposed to show that the function y given here is a solution to this differential equation. So quickly, what you do is you have your y, okay, as the solution being equal to c1 cos x plus c2 sin x. Okay, now to show that this is indeed a solution, what you have to do is you have to look through the differential equation and find the individual terms in terms of y from your given function. Okay, what I mean is that in the differential equation you have d squared y ds squared, so from this y of x you find d squared y ds squared, and we have only y, so here y is already given, so you don't have to go and find y again. So from this, then y prime, which is dy dx, would then give us, when you differentiate cos x with respect to x, you get minus sign, so you get minus c1 sin x. Okay, then plus c2 cos x. I hope you understand this differentiation. Now you differentiate it again, d squared y ds squared, and you get minus c1 cos s, because when you differentiate sign you get cos, but there's already a minus, so cos x plus or minus, I think it should be minus here, minus c2 sine x. Okay, I hope you get this. This is what we are differentiating again. Okay, so we have the squared y ds squared to be this, and we have y of x being equal to c1 cos x. Okay, let me write it well for you. C1 cos x, let me do this. Okay, C1 cos x, okay, cos x plus C2 sine x. Okay, and the differential equation is d squared y ds squared plus y should give me 0. So in order for this function to satisfy the differential equation, then its second derivative plus the same function should give us 0. So let's add these two. The squared y ds squared is giving us, let me use a different color, this one, okay, which is minus c1 cos x minus c2 sine x. And then y is also giving us the second one, this one, which is plus c1 cos x plus c2 sine x. So we are saying that if you put them here, the result should be 0 here. Okay, now this should be equal to what? This minus c1 cos x will cancel this, so that is 0. This one plus this will give you 0. So indeed, the whole of this is equal to 0. So since here should be 0 is equal to 0. Okay, after substituting your function into the differential equation, indeed we had the right side, that is this side, being equal to the right side, the left side equal to the right side, and this shows that this function y of x equals c1 cos x plus c2 sine x is a solution to the differential equation. This, okay. Now let's go to the next one. Show that y being equal to 1 over x squared minus 1. Okay, this one is actually a solution to of the differential equation y prime plus 2xy squared equals 0 on the interval of this. Now let's talk about the first interval, but not on any larger interval containing I. So the interval is I is equal to minus 1, 1. And you are saying that this function y being equal to that should be a solution to the differential equation this on this interval. Now why we are saying on this interval is that the function y being equal to 1 over x squared minus 1 is not defined when x is equal to either plus or minus 1. Okay, so when you check that is true, when x is 1 you get 1 over 0, and that is undefined, and when x is negative 1 you get the same thing, 1 over 0, which is also undefined. So it means that this function is not defined at a point x equals plus or minus 1. So any larger interval that contains plus or minus 1 will make this function undefined, and hence this function wouldn't be a solution to this differential equation. So that is the answer to the second part of the question. Now let's look at the first part, that we should show that y being equal to 1 over x squared minus 1 is a solution to y prime. We have y prime plus 2x y squared, okay, equals 0. So what you have to do is find y prime. Okay, but to differentiate, let me write this in a proper way for you. Y is the same as this. Okay, x squared minus 1 all to the negative 1. Then it means that y prime will be equal to, using the chain rule, I have minus 1 in front. Differentiating the bracket, I have 2x. Then writing the bracket back and subtracting 1 from the power. So this is what I have. I have in a fraction form, I have minus 2x over x squared minus 1 all squared. So this is y prime. Okay, this is my y prime. Let me say y prime. Okay, now there's a y squared somewhere here, but you know why. Okay, that is the solution we are just trying to say it should be. Okay, that is the solution given as your y. So now y is what? Y squared will just be squaring y, and that will be this squared. When you square 1, you get 1. So y squared is equal to 1 over, when you square the denominator, you have x squared minus 1. Okay, so what you have to do is put your y prime, which is equal to this one. Okay, so y prime is this. Let me use a white pen for you. This is y prime, this is y squared. So you come and put them back in this differential equation. The differential equation is y prime plus 2x y squared. Okay, so y prime is what? Minus 2x over s squared minus 1, then all squared, then plus 2x times y squared, and this is my y squared. Okay, so 2s times that, I'll get 2x over s squared. Y squared is, there's a square here, sorry, minus 1, then all squared, and this should give me what? 0. Indeed, this is the same as the first term, is the same as the second term, and there is a minus, so this will cancel this, and I'll have 0 equals 0, which shows that since both sides are equal, the function y equals 1 over s squared minus 1 is a solution to the differential equation y prime plus 2sy squared. And with the interval, I just explained it. Okay, so now let's go to the third one. Verify that the function y equals e to the negative 3x is a solution of the differential equation this. Okay, so here we have y, the solution, to be this. So in the differential equation, you have the squared y dx squared, and you have the y dx. So you have to find the y dx. Okay, and it's equal to minus 3 e to the minus 3x. I hope you know how to differentiate exponential functions. And then the squared y ds squared, okay, is equal to 9, because when you multiply negative 3 to negative 3, you get 9, and e to the negative 3x. So you put the squared y ds squared as this one, and this in place of this side, okay, and this side, and then you put y equals e to the negative 3s here. I hope you get this. So let's come back and we have the squared y ds squared to be what? 9 e to the negative 3x plus the y ds, which is minus 3 e to the negative 3x, then plus, or is it minus? I think it's minus 6y. Okay, yes, so minus 6, and y is what? E to the negative 3x. And we are saying that this should be equal to 0. Okay, this should give you 0. So what you do is you factor e to the negative 3x out, or you can simply add some terms. Okay, so I have 9 e to the negative 3x. There's a minus 3 here, there's a minus 6, so minus 9 e to the negative 3x. Okay, and this is the equation equals 0. So here, 9 of this, 9 of that, when you subtract, sorry, when you subtract, you get 0. Okay, so 0 equals 0. And then since the left side is equal to the right side, you have what? An identity, and this shows that the solution given y equals e to the negative 3s is a solution to this differential equation. Okay, so the last two questions are, some way you're applying that knowledge to find some values. Okay, so find the value of r if y equals e to the rx is a solution of the differential equation y prime plus 2y equals 0. So you know your y, okay, rx, and then y prime, you just need y prime. Y prime will be equal to what? R e to the rx. Okay, so you know how to differentiate your exponential function e to the rx. Okay, then this means that if I put everything back in this, I should get the right side. This is a solution. Okay, so y prime is what? R e to the rx plus y, which is 2, which is rx, e to the rx, so 2y, and this should give me 0. So I have r plus 2, then I factor e to the rx out. Okay, and this should be 0. But I have the product of two functions equals 0. Okay, but here we are saying that y, the solution is e to the rx, so it means that this is the solution. This shows that this will never be equal to 0, and hence r plus 2 should actually be equal to 0, because I have the product of this and this giving me 0. So you see that this is equal to 0, or this is equal to 0. But like I said, the function is actually not equal to 0, because it's the function we are looking for, or the function we are talking about. So it's not equal to 0, and hence it means that is this r plus 2 that is equal to 0. This simply means that r will be equal to what? Minus 2. I hope you understand this. So very simple like that. So you use the idea of solution to a differential equation to find your r. Very, very simple. Okay, so r is -2. Now with the last one, we say that find the value of alpha if y being equal to x to the alpha for x greater than 0 is a solution of the differential equation x squared y prime prime plus 4x y prime plus 2y. So here we have y prime prime, we have y prime, and we have y. So y is already giving us x to the alpha. We are looking for alpha. That means y prime will be equal to what? Alpha x. Alpha is an integer, sorry. X to the alpha minus 1. And y prime prime will give me, let me write it well here. Y prime prime, okay, y prime prime will give me alpha, alpha into alpha minus 1 x alpha minus 2. Okay, so you come and put these in your differential equation. So I have s squared into y prime prime is alpha into alpha minus 1, okay, then x to alpha minus 2, and plus 4x. I think I should write this in a different or on a different page, but I hope you've written the y prime prime and the rest down. Okay, so let me add a page to this. So I have the differential equation is giving us what? Let me write it back. S squared y prime prime plus 4x y prime plus 2y equals 0. And my y is giving us what? X to the alpha. And my y prime is giving us alpha x to the alpha minus 1. Okay. And y prime prime is equal to alpha into alpha minus 1 x to the alpha minus 2. Okay, so we'll put everything back in the equation. So I have s squared y prime prime is alpha alpha into alpha minus 1, then x to the alpha minus 2. That is my y prime prime. Okay, then plus 4x y prime is what? Alpha s to the alpha minus 1. Okay, I hope you can see this. Then plus 2y, and y is what? X to the alpha, and this should be equal to 0. Now I multiply s throughout. This is s squared, s squared through this. Okay, and I have alpha into alpha minus 1, then s squared times x to the power alpha minus 2 will give me x to the power alpha. My pen is not helping, but let's continue. X to the power alpha minus 2, alpha minus 2, let me write it like that, plus 2, because I have s squared and the same base. Okay, so since they are of the same base and they are multiplied, take one base, that is the x aspect I'm talking about, then you add the powers, then plus 4 alpha, then x to the alpha minus 1 plus 1, since this x is to power 1. Okay, and plus 2x to the alpha, and this is equal to 0. Now you do this, and I have alpha into alpha minus 1 x to the power alpha plus 4 alpha, okay, x to the power alpha plus 2x to the power alpha. Okay, and this is equal to 0. Now the same thing happens to that factor alpha x to the power alpha out. So I have alpha minus 1 plus 4 alpha plus 2, and I factor x to the power alpha out equals 0. Now I have the product of two things equals 0, but this is our solution, so it's not equal to 0, so rather the other side is equal to 0. Okay, so we have alpha into alpha minus 1, alpha into alpha minus 1 plus what? Plus 4 alpha. Okay, 4 alpha. Let me use the correct pen. Okay, plus 2, and this is equal to 0. Okay, if I expand the first term, I have alpha squared. Okay, minus alpha plus 4 alpha plus 2 is equal to 0, and then I have alpha squared plus 3 alpha, okay, plus 2 is equal to 0. And I realize that this is a quadratic equation, so to solve this, you say you multiply the coefficient of this one, which is 1, by 2, and you get 2, right? So you find the product of 2, that when you multiply you get 2, but when you add you get 3. It's 2 times 1, okay? And you add you get 3, but when you multiply you get 2. So that you split the 3 alpha into those products. So I have 2 alpha squared plus alpha plus 2 alpha plus 2 equals 0. So now I group them, alpha squared plus alpha in one bracket, then plus 2 alpha, okay, 2 alpha plus 2, this one 2 is in one bracket and equal to 0. So I have alpha out, alpha plus 1 plus 2 out, alpha plus 1 is equal to 0. So here I have what? Alpha plus 1, alpha plus 2, and it's equal to 0. And these two, we say that alpha plus 1 is equal to 0, or alpha plus 2 is equal to 0. And with this, we have alpha being equal to -1, or alpha being equal to -2. So for the values of alpha that will make the function, if y of x is equal to x to the power alpha, is a solution to a differential equation, this plus 4x y prime, I think I'm right, plus 2y equals 0. For this to be a solution to this, alpha should be equal to either -1 or -2, and this works. Okay, so I hope you understand the solution to a differential equation. It's just a function that satisfies the differential equation. Okay, all right, so in our next discussion we'll talk about how to find a differential equation given its general solution. Okay, thank you, and don't forget to subscribe to my channel if you have not subscribed. See you next time.